A new robot guide dog now offers fully autonomous indoor and outdoor navigation for the blind. This breakthrough promises to make crucial assistance widely accessible. Let's get into it. Let's start with a featured paper, Milo, a fully autonomous indoor-outdoor robotic guide dog, by Florian Guillemot and Christopher Pell from Milo, Quebec AI Institute. Milo presents a compelling and impactful application of robotics to a critical societal need, demonstrating significant progress towards a fully autonomous robotic guide dog. Here's a full breakdown.
First, our system is built on a modified robotic platform, which you can see represented here by its various input sensors. These include odometry, magnetic encoders, LiDAR, and a camera, all providing crucial data for the robot to understand its surroundings. Feeding into our system is an advanced perception stack, which starts with processing the RGB camera image. This involves segmenting the walkable path, detecting objects and pedestrians, and estimating depth, all of which are then fused into a comprehensive 3D map of the environment. Next, this 3D map is projected into a bird's-eye view, which serves as the input for our sophisticated navigation policy. This policy then makes the high-level decisions that are translated into specific robot commands like forward velocity and yaw rate. Ours, Milo, stands out by supporting both indoor and outdoor navigation, a capability not fully matched by prior works, which are often limited to one environment. Furthermore, it uniquely offers dynamic handler modeling and is open source, providing a more comprehensive and accessible solution compared to methods like RDog or Summer.
Up next, our second paper out of 3, DARWIN, Evolving Jailbreak, Adversary, and Guardrail for LLM Safety Evaluation and Protection by Weiwei Qi and Kuei Ren from the State Key Laboratory of Blockchain and Data Security, Zhejiang University. This paper introduces a novel evolutionary framework for LLM safety, addressing the critical and continuously evolving challenge of jailbreaking with a dynamic, adaptive approach. Let's break down its key contributions.
Let's start with the overall DARWIN framework, which creates a co-evolutionary loop between an attacker and a defender. The top half details the DARWIN attack system for evolving jailbreaks, while the bottom half shows the corresponding DARWIN guard defense that learns from it. Feeding into this, the DARWIN attack system acts as our evolutionary adversary, detailed in the top section. It generates new attacks by composing strategies from a strategy pool, and then uses feedback-driven evolution to mutate and refine its methods for success. Next, we have DARWIN Guard, which uses an online adversarial training paradigm to continuously improve its defenses. As shown in the bottom half, it takes adversarial samples generated by the DARWIN attack engine and uses them for continual updates to create a stronger guardrail. Finally, to ensure the guardrail doesn't become overly restrictive, we use intent-based robustness training. This involves feeding both harmful bypasses and useful benign rewrites into a mixed training reservoir, teaching the model to distinguish malicious intent from harmless requests.
Up next, our third paper out of 3, HijackKV, New Threat in Position-Independent KV Cache Reuse by Yiqi Zhang and Yuchen Yang from the Pennsylvania State University. This paper uncovers a critical new security vulnerability, KV cache hijacking, in recent position-independent KV cache reuse optimizations, highlighting a significant threat to LLM integrity and requiring immediate attention from the community. Let's break down its key contributions.
Let's begin by looking at the target system, where a shared KV cache pool is used to speed up responses. The critical vulnerability we've identified is that the KV cache for a normal piece of text, like text chunk 1, can be silently hijacked and poisoned by an attacker. To exploit this, we introduced the Hijack framework, shown here on the left under the malicious attacker section. This framework is responsible for crafting the malicious input that will poison the target system's cache. A key part of this framework is the optimized prefix, which is carefully crafted using a proxy LLM to encode a malicious goal. This prefix is what causes the text KV binding that poisons the cache for the benign chunk that follows it. Next, we see the attack's effectiveness when a benign user asks a related question. Because their query matches text chunk 1, the system reuses the poison cache, leading the user to get malicious answer instead of the correct one. Finally, by understanding this entire attack flow, from the attacker's prefix optimization to the benign user receiving a malicious link, we can do more. This knowledge allows us to provide crucial design insights for building more secure KV reuse systems that can defend against this threat. CacheBlend consistently achieves higher accuracy scores compared to vanilla, random, and epic methods across all benchmarks and models. While Cache Blend generally performs well, its accuracy is slightly lower than the full method across all evaluated scenarios.
Those were the top papers. Now, let's zoom out. ArXiv received 549 new computer science papers across 57 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into 5 big themes: LLM performance and safety, stable, adaptive AI learning, robust AI system defense, formal methods for AI safety, physics-informed ML solutions. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.